So I'm really pleased to be joined by Mark Warner, who is the co-founder and CEO of the Richmond, Indiana-based Liberation Labs. If you weren't already aware, Liberation Labs is a cutting-edge CDMO specializing in fermentation. They're revolutionizing biomanufacturing with their focus on precision fermentation, offering a cost-effective and scalable solution for producing bio-based products. So Mark, welcome to Protein Production Technology International.
Thanks, Nick. Appreciate the opportunity to chat with you today.
It's great to have you with us. Now, I've been following the fermentation industry closely, or pretty closely, and it seems as if there's a growing demand that's outpacing supply, and I guess that's kind of why you guys exist. So what are the main challenges hindering the expansion of fermentation capacity in the USA or indeed globally right now?
Yeah, I mean, like most in the space, the biggest obstacle is fundraising. It's, the infrastructure type that we're building isn't what venture capital often wants to do, and it's also not necessarily first of a kind what the infrastructure funds want to do. So it's made us take somewhat of a unique approach of a mixture of debt and equity that has kept us moving forward. But I'm sure you hear it from others when you talk to in the space that the headwinds on fundraising are real, and that's certainly probably the biggest obstacle. Also, just the products are still emerging. A lot of them have some level of offtake, but the fundraising quandary also comes into not all of these products have long-term binding offtakes today with big companies. So it's all of those pieces together that we believe are finally coming together, but it's certainly been a challenge over the last couple of years.
Mm-hmm. Now, in terms of the capacity crunch that I'm hearing about, let's have a look at the bigger picture. How could that impact research and development in related fields, and what kinds of hurdles are smaller companies facing due to that shortage of fermentation capacity?
I would argue that the impact is way worse to R&D than people even realize, in that they just look at it as total capacity. Part of the problem is the capacity that's out there is 40 to 50 years old, and it was built for other purposes, things like pharmaceuticals and biofuels. So it's not really well set up to manufacture these products. The example we like to use is, think if you're a great app developer for an iPhone, but everybody has flip phones. Mm-hmm. You can develop this great app, but then you have to make all kinds of tweaks to get it to run on a flip phone, if it can run at all. That's kind of what's going on in the industry. The R&D often isn't developing the process they want. They're having to redevelop the process that can run on the existing network. So, we're trying to bring that modern platform that really lets them get the performance they expect from these new strains, which all comes down to cost. As we talk today, you're going to hear, hopefully from me, a half dozen times, so much of it's about cost. We're making these products. We're not making them at the scale and the cost needed for much wider acceptance.
Mm-hmm. Now, Liberation Labs has some ambitious expansion plans. Where are you with that current facility? I've seen various pictures showing various stages of construction development, and the last one I saw, I think a few weeks ago, looked like it was coming on very, very nicely indeed.
Yeah, the progress on the project is going well. We're at about 60% complete on the project. All the major equipment's been ordered. We have all our environmental permits. Most of the concrete's done. The pictures you'll see show most, at least for the main building, the structural steel in and the equipment set. Mm-hmm. So it's progressing well. We're expecting to be operational first half of next year. So that is going well. As far as our future expansion, so this first facility is what we're calling a launch facility. Mm-hmm. It's 600,000 liters. It is commercial. It is profitable, but it's on the lower end of scale for commercial fermentation. We expect to build up to about 4 million liters at Richmond. We're currently evaluating expansion there. We have the land and utilities for it. And ultimately, we expect to build in 6 geographies worldwide. Initially, US, Middle East, and Australia are our targets. And we've done site selection both in Middle East and Australia, Europe, Southeast Asia, and South America secondarily. And that's really for the reason of, if you're a big CPG and you're buying some great novel ingredient, a whey that goes into ice cream or an infant formula component or something, the two things you don't want to hear are, one, it's only made one place in the world. And two, even if it's multiple places, it's not made anywhere near where your geography is. So it lets someone who launches a product in the US move to Asia, Australia, Europe, with the confidence there's both redundant supply and local supply. So we think, like I mentioned earlier, a lot of people talk about the total capacity problem. We believe the issues that need to be solved are much more than total capacity, how the facilities are built and where they're built from both a cost and market perspective.
It's interesting that you mentioned capacity again. I mean, how does your projected capacity stack up against the overall market? Are you poised to make a significant impact?
Yeah, the market today, there's about 60 million liters of fermentation capacity that's used to service this market now. We're looking to build about 25 million liters over the next decade. So in the range of 40-45% now. At the same time, given the age of that capacity, there's been more capacity come offline than been built in recent years. So we do think it's material. It's certainly not going to replace everything that's out there, but we think it's more than what is needed to fill the increased demand.
This is probably a difficult question to answer, but trying to get a more holistic view, what do you think is the ideal amount of capacity we'd need to satisfy the anticipated demand for new protein products? Is there a magic number or range that we should be aiming for?
I wouldn't say a magic number or range. You'll see a lot of management consulting studies that talk in the 5 to 10 times range. So that would take 60 million liters to 600 million. We believe it's probably in the 2 to 3 times range. Certainly it could be above that. In the 2 to 3 times range for a couple of reasons. We do think, there will be continued to be incremental increases in performance, which makes the equivalent build more viable. Plus, we also think to some degree, you almost can't build that much that fast. So, our kind of realistic target, we like to tell people, we think the industry is going to double to triple over the next decade. That's kind of a realistic target.
So we're going to talk about what lies beneath now. So what kind of special features or technologies have you built into your facility, or are you building into your facility to make sure that your process is as precise as possible?
First and foremost, it's built for the processes of today, not different products from decades ago. So first and foremost, it's built for food. Certainly we make things beyond food products, but most fermentation facilities running today weren't built to make food products, so they can struggle at doing it. So we're built to make it. The other thing is we can go from sugar to final dried product all on the same site in Indiana, and that's true of what's planned for our other sites. That's fairly unique today. Very often they'll do part of the manufacturing at one facility, go to an intermediate product and maybe take it somewhere else to dry or something else. That's problematic from a quality standpoint. It's problematic from a cost standpoint, and it's problematic from a sustainability standpoint. So it's not the ideal solution. And that's really what we're trying to bring, building the facilities, one, in the right geography. Part of the reason we built in the U.S. initially is it's where the biggest gap of capacity is. But if we're talking food proteins, it's really the only market today where you can sell a food protein. I worked 10 years ago for Impossible Foods. They've been talking to Europe about being able to sell their Impossible burgers in Europe for 10 years. And I saw an article recently that they're getting closer after 10 years, which is great. We want to see that happen there. But in the end, we need to manufacture where the product can be sold today.
Now, given the critical role of operational efficiency in precision fermentation, could you elaborate on how your facility design and infrastructure optimizes workflow, minimizes waste, and ultimately contributes to cost reductions? Because that's why these clients are going to be using you guys to get their products to market.
So we are designed to be a long-term, high-efficiency production facility, which a lot of the facilities today were built for pharmaceuticals where they may run 20, 30 different products a year. So they're designed more for flexibility. Neither is right or wrong, but they're very different goals. For us, for large-scale manufacturing, it's really about efficiency and especially recovery and yield. I started in chemical manufacturing 35 years ago, making food ingredients for the food industry, chemical and pharmaceuticals. I don't hear things like yield the way I did. It was almost a cult-like focus. That was the difference between 80 or 85% recovery yield was often the difference between whether you were making money or losing money. You don't always hear that focus today because it's more about just showing you can make the product. So we've really designed our facility for continuous stable operation, large scale and high efficiency. For example, our filtration steps are microfiltration step. Most contract manufacturers today have one, maybe a 2-stage recovery. We have a 6-stage recovery. And it's built more like a modern milk processing facility because, again, it's all about that recovery yield. So, we believe it is going to show materially different cost of manufacturing for the same process than facilities out there today.
Mm-hmm. You previously mentioned sustainability and miles to market. Now, that's a cornerstone of precision fermentation as well. There's so much excitement about this particular technology. Could you outline some of the specific strategies that you've implemented to minimize your facility's environmental footprint and ensure its long-term sustainability?
Sure. When you do a new facility like this, and I've built these facilities before, done the LCA or greenhouse gas analysis, and you'll find that between by far the biggest contributor is electricity and second is water. And electricity usually comes down to not just how much you use, but where is it coming from? Is it coming from coal? Is it coming from natural gas? Is it coming from other sources? So part of the reason we liked Richmond so much was half the facility, where the facility's located, local solar makes up about half of the substation that we're coming out of. So that's by far an advantage. We have the ability, should we choose to source things like hydropower, depending on the need for the rest of it. And the other thing is water. With a much more modern design, the ability to recycle a lot of water, we expect to be able to knock that down probably 50-70% from what we're seeing for current processes. So in the end, it all comes to those inputs. It's just math beyond the inputs. You got to drive the energy use, the natural gas, the power, and the water down to really drive that sustainability.
Mm. Now, data analytic plays a pivotal role in driving innovation in this particular field. Can you perhaps explain how you're harnessing data to optimize your parameters, accelerate product development, and enhance overall process efficiency?
Yeah, from that standpoint, it's really just bringing on modern design that, again, the instruments that we're using can monitor so much more than instruments of years ago. The ability to control the process better, understanding what to look for, what to monitor, and things like off gas, and use that for control of the process, which gives us a lot more efficiency. I'll be honest, I think there's definitely incremental areas that you can move forward on data, but I don't think it's a catch-all. You can't replace the overall basic design and performance simply by data. Certainly, AI has been interesting in that, as we use it more, AI doesn't have the bias necessarily that you and I have. A lot of times it's just looking at data and looking at dependencies, where to me, I may say, hey, it makes no sense that factor is driving performance. And that may be intuitive to me, but through AI, if there's really a strong correlation, it makes you drive down and say, well, it might not be intuitive to us. Why is that tied to performance, and what are we missing? So we do think those are going to be things that continue to increase overall performance.
You mentioned flexibility a little bit earlier. How adaptable are your facilities when it comes to handling different protein types or varying production levels? Can you easily switch gears as needed?
Yes, I would say, frankly, that's our biggest differentiator to the industry. We're built as a contract manufacturer. We looked at 20 different commercial processes when we did the design, and we tried to build in as much flexibility so there was very limited change to run any of them. And that's a difference between, again, if we go to a facility that was built for a different purpose, there's usually a lot more rebuild or upgrade required. So we've gone in from the beginning knowing we're going to serve multiple processes, as opposed to somebody who built a facility for a certain purpose and then chose to retask it. So we think that flexibility, the limited amount of capital for us to switch between processes, and just that overall performance and efficiency, we think that's actually our single biggest differentiator with what's in the industry today.
Mhm. Given the competitive landscape of the CDMO market, I mean, how do you or how does Liberation Labs' operational excellence and cost efficiency translate into tangible benefits for your clients, such as, I don't know, accelerated time to market or reduced costs, increased profit margins, and
Yeah.
so on?
Most of it is cost of manufacturing, especially for the better developed processes. And what I mean is, there's a lot of focus on fermentation. Obviously, these are fermentation facilities. But as you get into the people who've really run these facilities, and I'm included in that, you'll find out that the downstream recovery is often as much or more capital and contributes more than fermentation in the overall cost of the product. We've spent a lot of time optimizing our downstream and making it very significant in its capacity. We can run much more productive processes, meaning processes that make a lot more product per unit time than many of the facilities out there. So if we're charging similar to use our facility, but we can make 50, 60% more product, which is often the case, that gives a lower dollar cost per kilogram. As I like to say, we spend a ton of time running techno-economic models and we have waterfall charts and all those things. When you go to a CMO, you really want to know two numbers. How much does it cost me to operate there? How much product do I make? And divide the two. So while those other things can be great guidances, in the end, it comes down to product per unit time and the manufacturing cost. And that's where we think when people get to that level, they see a real significant difference on the unit cost we can produce compared to what's out there today.
Mhm. Let's talk about some of the KPIs. I mean, what key performance indicators do you use to measure the success of your CDMO clients in bringing their products to market? And how do you attribute specific outcomes to the value provided by your facility and services?
So in the front end fermentation, most of it really comes down to, how many batches you can get per year. We've designed our facility for 24-hour turnaround of the fermenters. From the time one fermenter is done to the next one, 24 hours or less. Very often, other facilities can be day and a half to 2.5 days. That's downtime. You're not making product. So that again gets to this, how much can be made per unit time. And then same with our downstream. We're set up to be able to make sure the downstream never has the fermenters be limited. So this is to where most of the processes we've modeled, we typically see 30, 40% more product we can get out per unit time than other processes. And we think that, again, all comes down to the bottom line. On the downstream, it's really recovery yield. We see most of the processes out there today operating in the maybe 70, 75% recovery. So if for every 100 kilograms of product I produce in fermentation, maybe I only get 75 kilograms out the back end. We've designed our process to target 85 to 90%. So again, that's the key one on the downstream, because to me, when people talk KPIs, there's a lot of them out there. They should always tie to your most important criteria, which for most of our clients is all around manufacturing cost. It's not that I'm leaving quality out. Quality is a given. Manufacturing cost only comes into it if you meet your quality standards. So you always have to meet those. But then it's that manufacturing cost that's the key differentiator.
Mhm. Now we're going to talk about one of your key philosophies, which is build with speed. Given the critical importance of speed to market in this biotech industry, what approaches have you taken to employed to expedite the construction and commissioning of that facility?
So we're managing the project internally. We've staffed up. Roughly a third of our entire company has deep experience in design, build, and operation of facilities. So that's first and foremost. We don't have the cost structure and the delay of having a third party, what they would call EPC contractor managing it all. We have a construction management firm we're partnered with, so that's let us move forward at significant speed. From the time, it's also the site we selected. We have loved the Richmond, Indiana area. From the time we identified the site to the time we had a binding buy-sell agreement on the piece of land and an incentive package from both the state and the local authority was 90 days. I've seen that take a year or two in other geographies. So Part of it is where we're building, and part of it's also we're building in the right area. The type of facility we're building isn't unique. They're used to building large manufacturing facilities like this. It's when people try to go to very novel areas that aren't used to seeing these facilities, then the state and the local governments just have a lot more questions because it's not something they're used to doing. So that certainly let us move forward. Also, we talked financing at the beginning. We were able to get an equipment financing mechanism very early in the project. That's a debt mechanism that there's a party that's buying the equipment on our behalf and leasing it back to us. It let us buy all that equipment almost 18 months ago now. Because when you build one of these projects, now realize 18 months ago, we were just coming out of COVID. I would say normally most of this equipment is somewhere between 6 to 12 months to get it procured and fabricated. Some of it has taken as long as 15 months because we were still coming out of COVID. So that's probably the biggest thing that helped us on schedule, was to get all that long lead equipment under order early.
Mm-hmm. Now let's talk about the team itself there. Precision fermentation is a complex field requiring specialized experience. Yep. Can you perhaps describe some of the specific backgrounds and experiences of your core team members, particularly in areas such as strain development or process optimization and scale up?
Sure. First and foremost, we're a manufacturing company, so we don't have strain development. We're all about the manufacturing platform. So the people we've targeted generally have decades of experience in design, build, and operation of fermentation facilities. Our head of engineering started with Cargill. He was a shift supervisor, worked his way up through engineering. Our head of process engineering was with another big company, Genomatica. She was involved in helping retrofit and run a major facility they had in Europe. The general manager we've hired to run the facility spent significant time at Amyris as their director of process engineering. They have sites in Brazil, elsewhere around the world. All of these people have also been doing contract manufacturing. So the other thing is, most of us have spent a lot of time not just building and running these facilities, but also, frankly, working at the facilities we're competing against now. Mm-hmm. When I was at Impossible Foods and others, we were using the contract manufacturing network out there today. These are the facilities we're competing against. So our knowledge of their capabilities and other things come from firsthand experience, not from us just, reading it in a third-party report. So it's that deep experience that we believe is a differentiator.
Mm-hmm. How's that knowledge been instrumental in shaping the facility design and sort of process optimization strategies and quality control protocols?
I would say it's because so much of the team comes with the actual experience of operating it. You'll often hear you got to start at the end and work backwards. People often tell me, it's so hard to design and build one of these facilities. And my answer will be correct. I've done that. But I can tell you, having been through the design, build, operating it efficiently and cost effectively is actually the hardest part. So having a team that's been through that whole life cycle, and when they're working on engineering, knows they're going to be responsible for running that site later and has that perspective. It all comes down to difficult cost-benefit decisions. We always want to put everything possible in a facility, but that also runs the cost up 50 or 100%. So you have to make tough decisions between what's really critical to base operation and what is a nice to have that you can decide maybe it's a capability you add later. So it's been that life cycle perspective, I think, that's really added value to our team.
Mm-hmm. Now, considering the team's deep roots in the biomanufacturing sector, could you elaborate on the strength of Liberation Labs' network within the industry? I mean, how do those relationships contribute to the company's ability to identify and capitalize on emerging opportunities?
Sure. My co-founder, Eitan Ben-Haim, and I came out of the industry. So I'll talk about him first. He'd worked at Phibro Animal Health for years, a fermentation company. He was a founder of his own startup that did work in the synthetic biology space. So he came at it from a perspective and a network of having worked on the synthetic biology side and some in manufacturing. In my case, when I left Impossible Foods, I consulted for 7 years, I worked for over 100 companies in the novel protein space. Part of the reason of founding this company was just seeing this gap. So frankly, the vast majority of the people we're talking about manufacturing for, many of them I consulted with over the years. So we do believe we have a good perspective of not just knowing the players, but knowing their capability and probably having more of a peek under the hood at many of these companies and their technologies than others in the space. And just the relationship. It's, every industry also relies on relationships. Do you trust the counterparty? You can do all the math, you can do all the diligence, but in the end, if you're signing up for a manufacturer, if we're bringing in a synthetic biology company, we need to trust their capability to develop their process. They need to trust us to manufacture it.
Thinking about the dynamic nature of this precision fermentation industry specifically, how does the leadership team at Liberation Labs leverage its collective industry experience to develop a forward-thinking strategic vision that positions you guys for long-term success?
Yeah, I would say it's by bringing in very divergent people. We've brought in a head of manufacturing that came in primarily from the food space, as an example. We've got finance people that aren't specific to manufacturing. They've come from other industries. So it's getting that broad perspective. We certainly have the very specific fermentation perspective, but it's then rounding out the team with people in these different skill sets, realizing it's not all, unfortunately, just about the core fermentation expertise. It's how you service those industries, and it's like all client interaction, understanding what's important to them. If you're a big CPG and you're making one of these novel ingredients, maybe a whey protein to go into a novel, ice cream, a non-dairy ice cream, it's understanding what's important to them in the way of quality, in the way of cost, geography, and it's being able to understand that really firsthand. There's often no substitute for getting people who've had experience on both your manufacturing side and the client side. They see it like the client.
Yeah. There's been a bit of a downturn in terms of investment over the past few years, certainly compared to those heady days of 2021. But fermentations remain pretty steady. So what are your thoughts on what's going on out there at the moment in the industry in terms of investment? And why should we be excited about fermentation, especially precision fermentation?
Yeah, I think, the reason you should be excited about precision fermentation is it's a platform that really can solve a lot of the problems we have out there. The question is how to get it to the right scale and cost structure. Certainly, the numbers I've seen, they've come down 50, 70% from the peak. I would also tell you, having done a lot of work in that peak, I think we all considered it probably a little frothier than it should have been. So by historic levels, the investment numbers are nothing like they were a couple of years ago, but they're still not bad. I think it's, the things we're hearing is what we always expected it would be. There's a lot more focus on, if you're going to get funding in this space, you have to convince people you're going to be at your targets, which very often is break even or better on cash flow within a couple, 3 years. It's, the longer term timeframes just, are not what they were as far as funding sources. It's really much shorter term. And when people put money in, of the belief that funding round is really going to get you to your milestones, you'll hear a lot more, you'll hear cases of people having gotten a large amount of funding, not hitting most of their milestones, and then having to go back out for funding. That was a case 3 or 4 years ago. Those are the companies that just really don't have a lot of hope to get funding. There's certainly funding out there for the right companies, but it's not what it was.
Now, finally, Mark, you said it's first half of next year. Is that right? You're hoping to be operational? So presumably there's some people behind the scenes hard at work lining up clients. I know you're not going to tell me who any of those clients are, but what sort of products could we expect rolling off the production line there in Indiana?
Sure. We have a pipeline of about 30 companies we're talking to. We're in later stage discussions, I think, with about 8 or 9. Food is certainly part of it. Things like casein, whey, the dairy proteins we've always seen be kind of the leader, as far as many of us have drank alternate milks for decades. So it just seems to have a little more customer adoption, which gives a lot of the big CPGs a little more confidence in contracting for those. So that's certainly a part of it. Infant formula components, things like lactoferrin, HMOs, those are products that there's a lot of demand for. They were made at large scale, at least the HMOs for the infant formula components today, and even things like biomaterials. So I would have told you, a couple of years ago, if you had asked me, I would have said it's most likely a food product and it's going to be for a startup. What I would tell you today is it's still probably 50% or better going to be a food product, but the non-foods are coming in there to where it'll be a balance. But the thing we've seen in the last year especially is a lot more of an interest by a lot of the big traditional Fortune 500 companies in our capacity, to where it's either their own process or they may be partnered with a startup. But if you're a big CPG and you're partnered with a startup, in the end, it's the CPG's money. They want to make the decision on manufacturing, and they want to be, somehow party to that transaction. So that's been something we've seen as overall, frankly, a positive change. We love the startup companies. We know them well, but in the end, the banks and funding sources want that credible counterparty with a balance sheet in the transaction. So we see that as a positive movement.
Well, you've got a government there at the moment in the USA that's thumbs up, I think, for the biotech industry. Let's hope that continues after the elections later on in the year. Yeah. Mark, it's been fantastic talking with you today. Can only wish you all the very best of luck with that project as it continues to unfold. We'll be looking forward to covering more stories in the future. Thank you very much for your time, Mark.
Thank you. Appreciate the time.